Let's talk about wave math and how to calculate energy, wavelength, and frequency of waves, particularly light waves. This is a wave. As you see, energy is being transmitted left to right by the wave. The particles of whatever it is that the wave is in are going up and down, kind of like corks in a pond, but the energy is being transmitted from left to right. One cycle of the wave, also known in light as one photon, is the full wave from start to repeat, and the wavelength is the distance from one crest to the next crest. It's measured in meters. Frequency is the number of cycles or waves that pass a point in 1 second, and therefore it is measured in reciprocal seconds, seconds to the -1 power, or 1 over s. If we don't change the conditions like the depth of water or the tightness of a guitar string or the medium in which the light is being transmitted, the wave always travels at the same speed, and speed is equal to the wavelength times the frequency. For the speed of light, we use 3.0 times 10 to the 8th meters per second. And that is symbolized C equals lambda, length, times F, frequency. Sometimes you see a little Greek character nu that looks more like a V for the frequency, but I prefer to use F. Remember, when you solve problems, there are several steps. First, you write down what you are looking for, and usually put a question mark there so you remember that that's what you're looking for. Then an equal sign, then what you know, what you're given, the multiplication sign, then you write a horizontal bar for the conversion factor. You put the unit you don't want in the denominator down the drain, and you keep the unit you do want in the numerator, which we call the addic. When you're ready for that, then the unit that you don't want will cancel out if you have the correct conversion factor. And then you do the arithmetic. So problem 1, what's the speed of a wave if the frequency is 20 reciprocal seconds and the wavelength is 10 meters? Well, as we know, we've seen before, the speed is equal to the wavelength times the frequency. 10 meters is the wavelength. We multiply that by 20 reciprocal seconds. We used to call that cycles per second. And we get 200 meters per second. Now, what's the speed of a wave if the frequency is 20 reciprocal seconds and the wavelength is 10 meters? You're looking for the speed, so question mark, and of course we want a unit in meters per second, is equal to 10 meters times 20 reciprocal seconds. So the speed is 200 meters per second. And remember that the reciprocal seconds is marked s to the -1, but it's the same as 1 divided by s. Problem 2. What is the wavelength if the frequency is 20 reciprocal seconds and the speed is 10 meters per second? The speed is the wavelength times the frequency, so if we divide both sides by f, the wavelength is equal to the speed divided by the frequency, or 10 meters per second divided by 20 reciprocal seconds, and that's 0.5. Notice reciprocal seconds drops out, it cancels, and we're left with 0.50 meters. Problem 3. What is the frequency if the wavelength is 1 times 10 to the -3rd meters and the speed is 10 to the 3rd meters per second? Speed is the wavelength times the frequency, so the frequency is equal to the speed divided by the wavelength, or 10 to the 3rd meters per second divided by 10 to the -3rd meters. Now when we divide, remember, we subtract exponents. So the answer then is 10 to the 3 minus a -3, or 10 to the 6th reciprocal seconds. Now remember, when you work with exponents, when you multiply tens to an exponent by each other, your answer is 10 to the sum of the exponents. So 10 to the 4th times 10 to the 3rd is 10 to the 4 plus 3, and 4 plus 3 is 7. 10 to the 2 times 10 to the negative 4 is 10 to the 2 negative 4. When you divide 10s to the exponent by each other, your answer is 10 to the difference of the exponents. So 10 to the 4th divided by 10 to the 3rd is 10 to the 4 minus 3, or 10 to the 1st. And 10 squared divided by 10 to the negative 4 is 10 to the 2 minus a negative 4, which is 2 plus 4, 10 to the 6th. All this should be a review of your math. Now when you work with light, you have to remember the speed of light is 3.0 times 10 to the 8th meters per second. The math is exactly the same, but the numbers are going to be either larger or smaller than what we've been used to. So we ask, what is the wavelength of light if the frequency is 1.0 times 10 to the 13th reciprocal seconds? As before, the wavelength equals the speed divided by the frequency. So 3.0 times 10 to the 8th meters per second divided by 1.0 times 10 to the 13th reciprocal seconds. Reciprocal seconds cancels, and we're left with 3.0 times 10 to the negative 5 meters. Remember, we subtract the 13 from the 8 because we're dividing numbers with exponents. You can also calculate the energy of one cycle or photon of light. That's a very small number because, of course, light is going to be measured in very small numbers. One cycle of light is very small. So the energy is equal to Planck's constant times the frequency. And Planck's constant is given here as 6.6 times 10 to the negative 34th joule seconds. So if we ask the question, what is the energy of one photon of light with a frequency of 1.0 times 10 to the 14th reciprocal seconds? Very easy. We simply multiply Planck's constant times the frequency, 1 times 10 to the 14th reciprocal seconds, and the 6.6 times 1 is 6.6. 10 to the negative 34, we're going to add the 14 exponent to that, and we're at 10 to the negative 20th. So the answer is 6.6 times 10 to the negative 20th joules. If we're given the wavelength instead of the frequency, you know how to calculate frequency from wavelength. So you calculate the frequency first, multiply it by Planck's constant, and you have your energy.